Example 13 is an example on combinations. Consider a group of 10 people where 5 are from Australia, 3 are from England, 2 are from Canada. We need to form a subgroup of 3. How many such subgroups are possible? So this is an example of a combination. In our main pool, we have 10 people in our main pool. And we are choosing a subgroup of 3. So what are the combinations? The combinations are given by 10 choose 3. Because the main pool has 10, the subgroup has 3, so the number of combinations given by 10C3, which has the value of 10 factorial over 10 minus 3 factorial, which is 7 factorial, times 3 factorial. And this can be evaluated using a calculator. Now, example 14, consider the same group of 10 people as in example 13. So we have the same group of 10 people. That's our pool, the main pool. We need to form a subgroup of 3 with 1 from each of the 3 countries. How many such subgroups are possible? So notice that the subgroup is categorized. In the subgroup, we need 1 Australian, 1 Englishman, and 1 Canadian. So our subgroup here is categorized. Since our subgroup is categorized, we ought to have the same categorization in our main group. So our main group has 5 Australians, 3 Englishmen, and 2 Canadians. So from this main group, we want to form this given subgroup, which consists of 1 Australian, 1 Englishman, and 1 Canadian. And what are the combinations? So in choosing this stated subgroup, we need to choose an Australian out of a pool of 5. So 5 choose 1. We need to choose 1 Englishman out of a pool of 3. So 3 choose 1. And we need to choose 1 Canadian from a pool of 2. So it's 2 choose 3. So the number of combinations can be written as 5 choose 1 for choosing 1 Australian out of a pool of 5. 3 choose 1 for choosing 1 Englishman out of a pool of 3. 2 choose 1 for choosing 1 Canadian out of a pool of 2. So the total number of combinations is given by the product of these 3 terms, which can be evaluated using a calculator. Example 15. Consider the same group of 10 people as in example 13. We need to form a subgroup of 3 with 2 from Australia and 1 from England. How many such subgroups are possible? So again, our subgroup is categorized. So we want 2 Australians, 1 Englishman, and 0 Canadians in our subgroup. So we need to categorize our main group in the same way. So we have 5 Australians in our main group. We have 3 Englishmen in our main group and 2 Canadians. So we have the same categorization of the main pool and the subgroup. So the subgroup and the main group has the same categorization. So we want our subgroup to have, we want this subgroup to have 2 Australians, 1 Englishman, and 0 Canadians. So we ought to choose 2 Australians from a pool of 5. We ought to choose 1 Englishman from a pool of 3. We ought to choose 0 Canadians from a pool of 2. So choosing 2 Australians from a pool of 5 is 5 choose 2. Choosing 1 Englishman from a pool of 3 is 3 choose 1. Choosing 0 Canadians from a pool of 2 is 2 choose 0. So the number of combinations is given by the product of these 3 terms, which can be evaluated using a calculator.